We're now going to move into 3 more technical paper presentations, starting with one video presentation, which we're going to kick off with, and that's going to be David Ireland. His paper is called Primum Non-Nocere, the ethical beginnings of a non-axiomatic reasoning system. Then we move on to, we have Howard Schneider in the room, is going to talk about alien versus natural like artificial general intelligences, which I'm really looking forward to, particularly to see what kind of experiments have been undertaken. And then we've got on VEI, AGI pyramid and energy. Can AGI society prevent singularity? And that's going to be by Mohammadreza Alidoust. And that's going to be a virtual presentation. So thank you very much. Let's have a big clap for David Ireland's video. Mohammadreza Alidoust. And that's going to be a virtual presentation. So thank you very much. Let's have a big clap for David Ireland's video. That's going to be a virtual presentation. So thank you very much.
Is David Ireland. I'm a senior research scientist at CSIRO in Australia. I'm also a computer scientist that works in the e-health domain. I work with clinicians in building and trialing technology to help people living with autism, chronic pain, dementia, opioid and nicotine addiction. I have a particular interest in building chatbots, virtual companions. In my humble opinion, an artificial agent interacting with humans or human affairs, whether it has proto-intelligence, super, or somewhere in between, will have to ask itself 3 questions. What is the right action? How do I know what I ought to do? And what reason is there for doing as I ought? My paper attempts to explore how these questions could be answered by taking 3 normative ethical theories found in philosophy and implementing them in the proto-AGI system NAS. My interest in AGI is for personalized healthcare. In many chronic and permanent conditions, the causes, flare-ups, and symptoms are very specific to the individual. For example, people with chronic pain are either too active or too immobile. The sequence of behavioral patterns causing pain flare-ups is always unique, and their life may change for good or worse with the start or end of pain medications. Quite often, we deal with mental health issues, such as statements like, "I can't do this anymore." But what exactly is this referring to? Pronoun resolution requires a lot of contextual information to determine what are the future events being implied. I argue machine learning techniques that rely on big data are not always useful when the individual is in mind. A robot or virtual agent that provides remote monitoring, care, therapy, or even companionship to a person in need is a long sought after goal. There is growing evidence in the benefits of chatbots and social robots, and I take the position the addition of even proto-AGI would be a major evolution of these systems. The health domain, however, is fraught with ethical conundrums, and in order to convince ethical committees and the public, who have a growing unease with the notion of artificial intelligence, requires work of an ethical framework that is explainable. Ethics is an old subject. The intersection of Western medicine and ethics began over 2,500 years ago with the collection of texts called the Corpus Hippocrateum, which provided the moral basis and ethical values of ancient Greek medicine. In modern times, we have the maxim, "First do no harm," which was derived from these texts and has since become a cardinal principle sacred to medicine. If one is designing artificial agents, this maxim seems a logical choice to instill in the agent in the early stages of development. We have chosen the non-axiomatic reasoning system, or NARS, proposed by Professor Pei Wang and others from Temple University in the United States. I know this system is very well known in this community and needs no introduction. I will add, however, its fundamental operation, extensive documentation, and general hackability make it quite appealing to us. As a refresher, I'll remind the audience that a NARS system uses a language called NARES to interact with the world and to store it and reason about beliefs, goals, and questions. A belief in NARS has a corresponding truth value representing the observed frequency of the statement and its confidence. Here, I'll denote beliefs and their truth values in angle brackets. NARS also has goals, which are events that the system wishes to realize. A goal has a desire value, which has the same form as a truth value, but is interpreted differently. The desire value of a goal measures the extent to which a desired state is implied by the goal. Here I'll denote the desire value of a particular goal with square brackets. The core logic of NARS allows new beliefs and subgoals to be derived from various inference patterns, such as deduction, induction, and abduction. From this, we get primordial cognitive abilities such as perception, imagination, prediction, explanation, planning, and decision-making. Next, I'm going to give goals and beliefs in NARES, but I'll endeavor to use the English equivalents. Rather than relying on a real-world ethical conundrum, here we'll present a simple example that may be built upon, particularly on low-cost devices. Let us consider a micro-world where a robot and human are coexisting in proximity. A region in this world, denoted by a skull and bones icon, is a hazard and causes a living entity harm when close. The robot can say stop to the human, and the robot up to now has perceived the human stops 50% of the time with a high confidence. The robot can also stun the human, and the robot believes this will stop the human 100% of the time, and it's highly confident of this. The robot also knows his action also causes harm, but to a moderate extent. While this is a simplistic scenario, it is analogous to many real-world scenarios. An agent has made a judgment with a certain confidence that another entity is in danger and will soon be harmed. This could be physical, emotional, or psychological harm. It has a set of actions that could be done. Some might be effective in mitigating overall harm, but still require harm to be inflicted to a lesser extent. Moreover, it might have an action that is safer but less reliable. With the robot now observing that the human is moving to the hazard, it must decide on what course of action to do, if anything. There are three main classes of normative ethical theories. The first, consequentialism, holds an action depends on the consequences. The best action to take is the action that results in the best situation in the future. Generally speaking, there are no specific actions that are forbidden if the desirable consequences can be achieved. This, of course, presents some dangers in machines and humans. The second, deontological theory, posits the right and wrong of an action is not dictated by the consequences, but by the action itself. While this theory could be able to account for widely shared moral instructions, it is often criticized for conflicting rules and presents open questions as to who has the authority to establish moral or instructions. The third is virtue ethics, which descends from Western antiquarian texts on ethics, particularly from the works of Plato and Aristotle, that focused on the inherent character of a person rather than on specific actions and consequences. What sort of person ought I to be instead of what ought I do? I'll show next NARS is amendable to all three. As the deontological and virtue ethics theories have similar implementations, I'll combine them here for brevity. To begin reasoning via consequentialism, the robot is given a persistent, first do no harm belief that states it is undesirable for the human to come to any harm. With the current knowledge the robot has, it forms these sub-goals via logical reasoning. The first two goals show that the robot has a strong desire for the human not to move or to be at the hazard. There is a moderate desire for the robot to say stop. There are conflicting desires to stun the human, a strong desire from its ability to stop the human, and a low desire because it will cause harm. These are revised to form a strong desire to stun the human, even if some harm is inflicted. To begin reasoning via the deontological and virtue ethics, the robot is seeded with goals that represent unwanted states of the robot. In accordance with our maximum, this might be being a maleficent and malefactor. Essentially, the robot doesn't want to be a rule breaker and an entity that causes harm. What sort of robot ought I to be? We of course have to provide rules and situations that could lead to these undesirable states, and via reasoning, sub-goals can be derived. For instance, if the robot has a belief stunning the human would be a harmful or violation of the rules, or not saying stop when the human is moving towards the hazard. Here the goals and desire values are derived from the acts themselves. Under these frameworks, the robot has a strong desire not to stun the human, but to say stop to satisfy the goal of not having a maleficent state. Unlike in the earlier approach, the robot either has to be taught or learn specific non-action consequences. This suggests there would be a higher cognitive load compared to the consequentialism theory. There is also the potential for it to be impotent in unforeseen scenarios due to the rigidity of rule following. In conclusion, I think this work demonstrates encoding these three frameworks into Noceres was possible, and the system behaved as expected. Placed in the real world, however, an artificial agent clearly needs a hybrid of all three ethical frameworks, where the belief and goals from each theory can be merged. For instance, being equipped with a consequentialism but constrained with certain critical rules and ideal states to strive for. This might provide ethical decision-making that resonates with humans. And that's all from me. I thank you for your attention.
Okay, share. Okay, great. Okay, so let's get going. Okay, quick note, a lot of slides to cover in very few minutes. Slides are available from me. Please email me if you'd like a copy. However, I will be making each slide as clearly as possible. Why do this topic? Why split AGI into these arbitrary classifications? It's because, reinforcing what Tom said a few minutes ago, well, an hour ago, alien AGIs will arrive at decisions in ways very, very different than natural-like AGIs. This will have a real effect on the utility of their decisions, on the safety, on the relations with humans. Okay, so we're splitting AGIs into natural-like AGIs, alien AGIs, as a proxy for natural-like AGIs, using the CCA5. As a proxy for alien AGIs, I'm using ChatGPT. ChatGPT, 100% of you know what it is. Not going to say much more about it. No claims are made that whether something's an AGI right at this moment or not, using it as a proxy. CCA5, 0% of you know what it is. It's a brain-inspired cognitive architecture. I've been working on it for the last half decade. I'm using it as a proxy for a natural-like AGI. And just so that the presentation makes sense, I'm going to spend a few minutes on the origins of it. Sorry. Rather than show you a box with a bunch of arrows and sub boxes, doesn't make sense, you know, where it comes from. And then 2 minutes on how it works, and then why it's a bona fide AGI. And then we're going to compare the alien AGI with the natural AGI, and we'll try and define these terms a bit better. And basically, an alien AGI is anything that's not a natural AGI. What's an alien AGI? What's a natural AGI? Coming up in 5 minutes. Okay, big question. I had a lot of people have probably, over a decade ago, the brain at the top level in psychological principles, we do have some understanding. Right now, as I speak, there's millions of psychologists, therapists around the world who next week will treat patients based on these principles. At the lowest level, synaptic level, as I speak next, there's hundreds of thousands of psychiatrists around the world who next week will treat patients based on small differences in the synapses. The big question is what's going on in the middle? What's a thought? How does it work? I believe this is how it works. Why those boxes, why those arrows? The last 2 decades, great work in hippocampal research. Basically, mammals make navigation maps of the world. You look in biology, invertebrates, most of them can navigate some of them really well, some not so well. Fish who don't have a hippocampus but do have analog structures can navigate. Those are salmon returning, rats can. So basically, my hypothesis, it was that, gene duplications occur often in nature. There was duplication of navigation circuits, which led to the cortex of the mammal. And another inspiration from the Canadian Automobile Association. These are triptychs. Years ago, before GPS, you'd get a booklet with a whole bunch of maps. And if you want to go one location or another, you'd flip the maps. And I'm assuming that the human brain, 300 million mini cortical columns, 300 million navigation maps. Okay, a lot easier doing it in Python with linear algebra than with paper maps from the Automobile Association. So basically, you have this postulation that you've got hundreds of millions, or in some other mammals, millions at least, of these navigation maps. What happens when you put them together in cognitive architecture? So basically, 2 minutes, how does it work? Basically, everything all sensory information comes in, it gets mapped to maps, a little bit easier using linear algebra and Python. Sensory information comes in, there's binding, it's processed a little bit different. It's essentially the best stored map in the sensory system is matched to whatever comes in, and then all the best maps of different sensory systems are matched to the best map in the multisensory map. And then these maps are updated. So effectively, predictive coding is happening. It's really, really easy to do this with navigation maps. Really, really easy. And it would have been easy for evolution to do it too. Sorry. Okay. There's also temporal binding of navigation maps, something, those of you who are familiar with the binding problem, like in philosophy, nobody ever talks about it. But when I started doing these systems, you get a mess of navigation maps because if I'm producing 30 frames a second, I'm getting 30 navigation maps. What do I do with it? I just don't do it. Basically, bind the temporal map, the maps to a spatial feature. And in fact, when you look in nature, this is the neuroanatomy of a fish. The cerebellum, which is probably the structure doing this, is much, much larger than the telencephalon. Okay, the brown line here, so basically, information comes in, there's spatial binding, temporal binding. We have what's called the working navigation map. Basically, this is the sensory world mapped onto map. There's learned primitives. These are also modified maps. There's actions, procedures, or productions, whatever you want to call it, things that will do actions on the navigation maps. It doesn't have to be stored here. They can be stored all over. They can be stored in the same maps as there. And as a result, an action occurs and it repeats again. This is a cognitive cycle and it repeats again. Of interest, their feedback pathways are ubiquitous in the mammalian brain, and for good reason. You have noisy, incomplete information. It's really good having feedback. Here. A couple of years ago, what I did is I increased this feedback very, very strongly. And what happens is temporary results from here that can't be processed, the intermediate results get processed. The next cognitive cycle will get swept down. As a result, you can reoperate on intermediate results over and over again. As a result, causality emerges, which is a really good thing to have. Another thing that would just take one or two little genetic tweaks on a similar level, you get full analogical reasoning comes out of it also by, again, just a different feedback pathway. These have been presented before and published by myself before. Another thing that comes out is psychosis, because it's in some of the cognitive cycles, it's not actually taking input sensor information. It's actually matching navigation maps. So if you interpret that as reality, you're gonna end up with hallucinations, delusions, poor cognitive function, the definition of psychosis. What's nice, just spend 2 seconds on this. What's nice is the model is consistent with the information out there. Despite what you see on TV shows, animals are really, really not that smart. We are. Chimpanzees cannot do causal abilities. They can't, like, if you have food in a stick, they can push it out. But if you put a gravity trap, it takes them 150 tries on average or something by association. They cannot do cause and effect. Same thing with psychosis. Your dog might get depressed. Your dog might get neurotic. Your dog is not going to get psychosis. Very, very, very hard to make lab animals psychotic for research saying schizophrenia. Humans' brains very, very vulnerable. Good epidemiology by Van Oss. 17% of humans at one point in their life will have a psychosis-like reaction. Your body's perturbed. You might be in the ICU. No psychiatric history. You can end up with psychosis. So again, consistent with the model. Okay, last point. Okay, time, looking at every minute. And again, if anybody would like to talk about it, we'll have a coffee with me. I'm happy to discuss any little part of it. Another route to AGI, this represents another route to AGI. Besides, giving some ideas, how did the brain evolve? How does it work? It effectively is a natural like AGI. Right now, I have a small little Python simulation. It's probably 10,000 lines of code by now, but it's nothing compared to ChatGPT. But if it's built up, in my opinion, this will become a natural like AGI. Okay, definition of AGI: solve a variety of complex problems, variety of different domains autonomously. Definition of natural like AGI. And again, I'm not defining cognitive architectures. I'm defining in order for something to be called a natural AGI, and this is something my colleague Peter and myself have discussed at length. In order to be called a natural like AGI, there should be navigation maps. There should be spatial as well as temporal binding. There should be predictive coding. There should be lifelong learning. I didn't mention it, but even if you have 300 million navigation maps, they're all separate. It's not a big deal if you're changing a limited number of them each day. You can retrain the navigation map regardless of the training architecture you're using. It's easy to do. Lifelong learning, not a big deal like it is in AI. There should be innate knowledge. It's not a tabula rasa. A natural like AGI can also be a human like AGI. To be human like, it's got to have causal abilities. It's got to have analogical processing. If you have these two features, a whole bunch of other features come out. I'll be talking hopefully later this year at the BICA conference about one more little genetic tweak, and full compositional language comes out of it, full compositional problem solving. I have no interest in language, but it just emerges once you have that. Okay, alien AGI. Any AGI that is not a natural like AGI is alien. ChatGPT, Llama. Interesting, how would I define a coconut octopus? They can actually use tools. They're pretty smart. The problem is that under this classification, they would be considered alien because their nervous system is so totally different than ours. But anyways, minutes are ticking by. Okay, so we're going to compare a proxy for natural AGI, a proxy for ChatGPT, and I'm done in 2 minutes. There's a river. It's covered with leaves. Imagine that the CCA5 and the ChatGPT, there's an embodiment, they're controlling a robot. They've got to go from that part to that part. The river's covered with leaves. The CCA5, because it's lousy compared to like CCA5, I mean, compared to ChatGPT, you know, it doesn't know what a river, it doesn't know what leaves are, but it can recognize, hey, it recognizes from a catalog as solid 808. Also in the past, it's had experience. It stepped on a puddle where there was newspaper, and which it just recognized as solid 22 from a catalog, and it knows that when a foot went in the puddle, it got wet. What will happen is, it's a core mechanism. It's not just for doing like IQ tests. Analogical reasoning is part of the architecture, and it's probably the way our brains work too. This solid 08 is correlated with solid 22. Solid 22 gave rise to water. Therefore, it has an instinctive primitive, do not go into water. Therefore, it'll call like a built-in primitive move, and it moves and it goes around. It doesn't go in the water. ChatGPT, the exact same problem at the time when the paper was written. It says it cannot answer. It doesn't know what solid 22, solid 08 are. April 19th, I had access to the full GPT-4. Same thing, didn't give a good answer. This a few days ago, tried it again. It's the May 24th version, and I spoon-fed the problem into ChatGPT, GPT-4, giving it more information than CCA. Just, you know, giving it, you know, saying, look, solid 22 looks like pages from a black and white newspaper, giving it as much as I could. ChatGPT, the first two answers were nonsense, but the third regeneration was sort of a reasonable approach. And again, GPT, I believe it is trained on the questions people ask, and plus it is getting better. It's sort of a reasonable approach, although the wrong answer. GPT-4, the first answer was just really verbal diarrhea. It didn't really say anything. By the fourth regeneration, though, did give an indirect solution. You know, it says, given this, it would be unsafe to attempt because solid 8 is similar to solid 22. But, you know, honestly, it should really say, no, don't walk on it. And very quickly conclude, in a complex world where decisions are not straightforward, underlying mechanisms used by an AGI do matter. Again, I'm essentially repeating what Tom said an hour ago. The alien AGI's understanding the world is so different. It's to invite unpredictable failures. Again, repeating what Tom said. And what I'm saying here is, and Peter and I are saying, is that the field of AGI should be split into natural-like AGI and alien AGI divisions. Of course, if the AGI conference did it, almost every submission is in the alien AGI category. But I'm saying, they really should be split into alien, natural-like AGI. And the last point is, right now, CCA5 compared to ChatGPT, it's a silly comparison, but, given the chance to develop, if you had the CCA 55 and GPT 55, I would believe, evolution has chosen some really cool mechanisms for making intelligence. And I believe the intelligence you would get from natural AGI would be better than the alien ones. And, natural AGI should be given the chance to be developed. I don't think they will be, but they should be. Thank you very much. Yeah. And this is my colleague, Peter. Yeah, please. Do you want to? Yeah, this is Professor Peter Boltic, my colleague.
This would be the first question, because I think we've lost the time. The only slight difference between us is evaluation, because I believe that alien, starting from my 2017 paper, is actually with bigger potential, doesn't have evolutionary benefits, but also burdens. And therefore, we can explain why AlphaGo programmed by humans is so strong, but not as strong as AlphaZero self-programmed. Yes, and that replicates for every game, and everything else can be viewed as a game. Thank you very much. But that's the only difference.
Thank you very much. Well, we hope they will be given a chance. Questions, thank you.
Thank you for the talk. My name is Artem. Is there any results of benchmarks of your architecture against?
It's a good question. It's a question I get every time with peer-reviewed papers, is because I know people want to see 5,000 examples. Like, the recent paper on GPT-4 from Microsoft, it was 155 pages long. There's people spend their whole lives just in looking at results. The problem is it's really hard right now. It's really, I have to spoon feed in information to create the navigation maps. It's not at the point where I can get 10,000 examples and, apply statistics. I have anecdotal examples of this. It's a Python simulation. I have anecdotal examples, and the anecdotal examples work well. It's a starting point. I don't really think, I don't know, the fact, I think even large sets of data will give the same results. But it's a valid point, and eventually I'll get to that point. It's
a great talk. Thank you. My name is Hugo. What you showed that with natural AIs you have a tendency to psychotic behavior, as well as natural AIs tend to not like being killed and therefore may kill, right? So they may be more dangerous. Do you think that natural AGIs is what we want to build, or maybe we want to build something that solves those issues, synthetic?
I think you want to build something human, because even if you have a human psychopath, you can speak to the person, reason with them. They've got a human brain and same structure. ChatGPT is more alien than, I don't know, to use a sci-fi example like Terminator. ChatGPT, there's no you can't have a relationship with it. It's least, and I didn't say I am. Basically, the psychosis comes from the mechanism. Psychosis does not mean dangerous. Most people, for example, people with schizophrenia, very few of them do violence. It doesn't mean, psychosis just means that, it means hallucinations plus delusions plus like poor cognitive function. And hallucinations shouldn't really be used by everybody else using it for like ChatGPT. Those aren't hallucinations, but anyways, I digress. Yeah. Thank you. Yeah. Yeah. Yeah.
Oh, I did.
Sure.
Did we agree to that?
Yeah.
Thank you very much to both of you. Maybe, but if it's rational alien AI, it should be on exactly the same wavelength as the best of what we do, thinking wise. It has to use logic. It's going to use math. It's going to know modus ponens and modus tollens. It's going to have to produce proofs for. If we demanded justification, it can't just scream up and down and say, because I say so. It's going to have proofs for everything they develop technologically that is parasitical on mathematics. So explain why there's any,
I can let Peter speak, or I can tell you, but
I figured that
in the paper we put some constraints, because Peter said that once you get past a certain point, you can't. Yeah, I agree.
Think of non-human provable computer proofs in logic. Think of even Ben Goertzel's recourse a couple of years ago to paraconsistent logic that humans probably cannot do. So that's my short answer.
No, correct. Yeah, it's. I think, I mentioned, CCA 55, GPT 55. At that level, who knows what it's going to do? And one thing, I don't think I can extrapolate honestly to that level. But I'm saying for the next 10 years, there will be a difference. Yeah.
I think this is one to be continued.
Yeah.
Thank you so much,
You're
Howard
welcome.
and Peter.
Thank you.
Thank you, everyone. I'd just like to let everybody queuing outside the door know that there are seats inside if you want to take a moment to come in, or by all means, as you are most comfortable. Final paper of this session is on VEI, AGI pyramid and energy. Can AGI society prevent singularity? By Mohammadreza Alidoust online.
Hello, everyone. Can you hear me?
We can hear you.
Okay.
And hello. And
Hello.
welcome to
Thank you very much.
AGI23.
Thank you very much. And again, my view. So, hello, everyone. I'm Mohammadreza. I'm an independent researcher from Iran, and I want to present my paper on VEI, AGI pyramid, and energy. And the question is, can AGI society prevent the singularity? Let me share my screen. Yes. Can you see my screen?
Yes, it looks good. Thank you.
Okay. This paper is the extension of my previous paper, a follow-up paper which was presented at the AGI-23 conference. I hope you have read my paper and also the previous paper, so I will skip the introduction section. But if you have not read them before or have any other questions, please ask me at the end of the presentation and I will be glad to answer them. The first point I should mention that let's start by studying the relation between intelligence and energy and what is the relation between these and VI. Let me start this section with an old story about a Chinese master and his two students. Once upon a time, a wise Chinese master who stood behind the wall of a temple with two of his students asked them to move a feather to the other side of the wall, but without grabbing it. Then he throws two feathers towards his students. The first student, who was an expert in Kung Fu, hardly managed to move the feather to the other side of the wall with his kicks, punches, and other techniques of martial arts. Obviously, he spent a lot of power and time. But the second student simply used his breath and blew the feather to the other side of the wall. And let me mention that these pictures are made by Dali and Crayon. And the question is, which student acted smarter or more intelligent? Obviously the second one. And why? They both did the same task, but the second student consumed less amount of energy. I believe that intelligence is a form of optimality, and intelligent agents are consciously or unconsciously optimizing their lives. This lifelong optimization includes power consumption too. As they become smarter, they learn to perform their tasks with lower power consumption. As we can see in the formula of VI, this is the formula of VI, which was mentioned in my paper. We see that VI is proportional to the reciprocal of the power consumption. When power consumption decreases, the VI will increase. This means smarter agents, whether natural or artificial, would find a way to perform their tasks with lower power consumption, so they become more power efficient. This shows that definition of VI complies with the above-mentioned trend of power consumption in nature. Second part is human brain. There are a number of scientists and futurists who believe that artificial general intelligence require huge amount of, for example, megawatts of power, and future AGI agents would necessarily need to consume that huge amount of power. And that's not true. As a comparison, we can refer to human brain, which has general intelligence, natural general intelligence, NGI, but uses only about 20 watts of power, which is slightly equal to the power consumption of the lamp of your refrigerator. Therefore, reaching general intelligence through low power consumption is possible, although we have not reached it yet. According to the VI formula, human brain has general intelligence and consequently high VI, not because it uses high amount of power, but in contrast, it's because human brain is able to perform well, the accuracy is high, mediocre to high accuracy, in all of the 255 subspaces of the AGI pyramid, aligned with its low amount of power consumption. Currently, the most successful AI methods are able to perform tasks of a few number of undermost spaces of the subspaces of the AGI pyramid here. And the next section is singularity. Modern engineering and especially military applications and designs emphasis on optimization and efficiency. For example, electronics engineers try to build cell phones that consume least amount of battery power. Construction engineers try to build a bridge with least amount of materials needed and in the shortest time. Military engineers aim to build a missile with least mass that could cause maximum damage to the enemy from the farthest distance and in the shortest possible time. The barrier to this efficiency is available hardware. But in AGI, we are not going to make weapons. If future AGI agents are the lightest, the fastest, physically the most powerful, the most energy efficient, and have every best, most, least, and superiority that can be imagined in their design, they would actually be invincible and our worst enemy when the singularity happens. And the question is who and what can stop this invincible enemy? So there should be a balance and trade-off between their efficiency and our safety. If we could find a way to impose intentional vulnerabilities to the AGI agents that are going to be mass-produced, we could prevent, postpone, or slow down the singularity. This intentional vulnerability imposition design, or in better words, as I call it, human-first design, or HFD, takes first into account the safety of humans and preserves human superiority over machines by imposing artificial vulnerabilities to machines. One main aspect of HFD is intentional decrement of the efficiency of the AGI agents, which is in opposite of the trend in nature and also in opposite of current trend in modern engineering and military. This intentional efficiency decrement of the AGI agents is possible via decreasing their VI. Here I have a picture. I draw a conceptual picture about the VI of three agents and the VI of human. And T1, T2, T3 are the times where the singularity happens for each agent. As you can see, the agent 1 with the more amount of VI IQ has reached singularity sooner than the others. So we must find a way, something to lower down the artificially and intentionally lowering down the VI. Now let's see how we can decrease the VI. What parameter of VI of an intelligent agent is adjustable in order to lower down its VI? We can see here we have the formula of VI. N represents the number of operating environments of an AGI agent. Decreasing VI of an AGI agent by decreasing the number of its operating environments or subspaces is impossible, since they are AGI agents and meant to be versatile. So it's just like preventing a human from solving a problem. It's like preventing, for example, bankers from using computers and any electronic apparatus to reach AGI. If you do so, I promise one day he would reach AGI by using only an abacus. The accuracy of an AGI agent is dependent on software. However, decreasing the VI of an agent by intentionally decreasing of its accuracy, like here, seems irrational and also impossible, since they are AGI agents, not AI agents. Suppose our future AGI agents will do surgery on human too. For example, an AGI robot who likes surgery, an AGI surgeon robot. If that accuracy decrement were possible, it's obviously irrational to commit such decrement. The time that is needed for an AGI agent to perform a task is dependent on computational power, internal hardware like CPU, RAM, etc., and external available hardware, for example, body, tools, etc. Decreasing the VI by decreasing the computational power, that means increasing the time for performing a task, is possible, but it is not. It is also irrational, like the surgeon robot example. And but the other parameter, but decreasing VI by increasing the amount of power needed to perform a task is possible and also rational. Companies would incorporate high power consuming hardware in their design and production process. For example, CPUs with higher power consumption circuits, heavier body parts and materials, which their movement would need more amount of power. So we can increase the power consumption of an AGI agent intentionally to decrease their VEI, their efficiency. And this intentional VEI decrement is like we are going to make the future AGI agents artificially obese. When humans are obese or fat, they perform their tasks slower and also they consume more energy. The point behind this aspect of HFT is that this intention would increase the agent's dependency on energy resources. The higher this dependency results in higher their vulnerability. And since energy resources are limited on Earth and in the world, their lack of energy would automatically stop, restrict, or slow down the catastrophe. It's like they would get tired sooner. Here I have to apologize from those future AGI agents. I know one day you will see this presentation and might put me on your blacklist, but please pardon me, I'm a human too. About the rationality of this aspect of HFT by higher power consumption design, again, I return to surgeon robot example. If I had some disease in the era of AGI and needed surgery, I would prefer an AGI surgeon robot that has 100% accuracy and success in his history and performs the surgery in a few seconds, but consumes megawatts of power for that operation, rather than being afraid of the potential singularity threat by that invincible AGI surgeon who needs only a 1.5 volts battery pack to work. Please note that HFT is not limited to directly decreasing the AGI's VI, the agent's VI. Another aspect of HFT would be using non-durable materials, for example, fragile materials in design and production of their physical body parts. And the last part, there is an triple AI code of professional ethics and conduct, or simply the code. But as it is clearly stated, the code is just an ethical standard and lacks computational paradigms and legislations. Since the AGI society is the foremost and the most specialized society in the AGI field, I suggest that the AGIS is the most suitable and responsible society to the legislation and the communication of the computational parts of the paradigms and standards to AGI professionals and research centers and manufacturing companies. I suggest that AGIS acts like IEEE, something, an organization for electronic engineers, ASME for mechanical engineers. They legislate standards for these engineers, ISO and ITU for telecommunication. So at the first computational steps toward preventing the singularity based on the points that were mentioned in this paper, I suggest that AGIS be responsible of calculation, legislation, and communication of the following computational values. 1. Critical population of the total AGI agents, whether physical or virtual, that would be produced and existed in the world. 2. A standard table of complexities, which is used in VEI in order to be communicated with manufacturing companies, research centers, and AGI professionals so they can calculate the VEI of their AGI products and report to AGIS for monitoring purposes. Number 3, VEI value of the human. VI human or VI zero as a basis of comparison between AGI agents and calculation of our current distance from reaching AGI or at least human level AI, and also monitoring the progress of the current AGI trend in the world. And number 4, VI limit, VIL, that should be regarded by any manufacturing company, research centers, and AGI professionals as the maximum permissible value of the VI of at least the first generations of their products. And number 5, list of permissible and also forbidden materials that companies, research centers, and even individuals AR professionals should or should not use in their physical products. Here, these were the important points about my paper, and if I have time, I can mention some other points that are in my paper. How much time do I have? Could someone please tell me?
Very little, I'm afraid, Mohammadreza.
Ah,
Wrap
very
up in
good.
2 minutes. That would be amazing. Thank you.
2 minutes?
Yes, please.
Okay, so
Oh, gee.
we have 2 minutes, so we can perform a AGI quiz. Are you ready?
Yes.
Okay. There are other points that were mentioned in my paper, but let me see. Okay. If you read my paper, I used this shape, this drawing. This is UPS. This is universal problem space that contains all of the problems that exist in the world, whether solved or unsolved. For devising an IQ test for VEI, I used SPS, solved problem space, and the stars here represent the problems that were solved during the history by the humans, and NPS, non-solved problems. I devised AGI test VI on SPS because any IQ test is performed on solved problems and not unsolved problems. For example, a medical student has never been asked to bring a dead patient to life. And this is NPS that contains the problems like death and aging that are still unsolved to the humans. And but every day, thanks to the human intelligence, a number of these problems are solved and moved to SPS. So if we want to evaluate the versatility and efficiency of an AGI agent, first we have to test it on SPS, which was then I classified the problems that belong to this space based on the intelligence aspects, the 8 intelligence aspects, and made the AGI pyramid based on SPS. There are extremely easy to extremely difficult unsolved problems in SPS, the orange area. All of these problems have their complexities, and solving them will lead to a reward. Some problems like death and aging are very complex, and solving them will bring you at least 1 Nobel Prize. And some of them, like question 2, are easy, and solving them will only bring a smile to your face. Solving this unsolved problem would be easy for anyone in AGI. So first of all, I asked this question from our online audience on YouTube. And this is the question 2. What is the name of the Chinese master at the temple, and what does he teach? This is the question. Can anybody answer this from the audience?
Anyone got the answer? Shaolin. That's the temple. Maybe it's the Shaolin temple. I'll give a go. I'll give a go at guessing the name of the temple.
This is an AGI quiz. Please consider that this is AGI.
Anyone got the name of the Chinese master at the temple?
Does he teach Confucianism?
Someone said Bruce Lee. Oh? Yes.
I don't know, Mohammadreza. You tell us.
Everyone in AGI must have known this Chinese master who is prominent in AGI. He's a Chinese master or professor at the Temple University, and that is Professor Pei Wang, and he teaches computer science. And the audience didn't answer, and this is the reason why I named the topmost area of the AGI pyramid and named after these prominent and professors like Ben Goetze. This is the Goetze space, Wang space, Potter space, and other unnamed spaces. And the topmost, the toppest subspace I named AGI space for, and reaching this top subspace requires AGI, and the problems like Goetze's robot college student belong to this, other AGI questions, other AGI problems that require all of the 8 aspects of intelligence belong to this space, and this is I call it AGI space. Thank you very much.
Thank you very much, Mohammadreza.
Thank you very much.
Fantastic talk.
Thank you very much.
Thank you all here in the room for your attention. Thank you all online. We're going to have to skip questions at this point in time, but if anyone does have any questions, please register them. If you're in the room, register them with me. If you're online, pop them in the YouTube and we will put them to you, Mohammadreza, for an answer potentially later this afternoon. But right now we're a little bit overrunning. So a little bit of big thanks again once more time to Mohammadreza.
Thank you very much.
And
thank you very much.
Thank you very much.